Good morning, friend. The $1 trillion claim break future capabilities. Advanced propulsion system making journeys to distant asteroids, companies and nations. The private sector pioneers, the startups and established aerospace international cooperation and competition, the geopolitical landscape of space mining, impossible space debris and environmental concerns, responsible and sustainable practices, legal and ethical dilemmas, ownership of industries, how asteroid resources could transform electronics, opening up space colonization vision, what a mature asteroid mining economy looks like humanity. This is the image asteroid mining the $1 trillion space economy. Good morning, friend. Below is a focused 2000 analysis and 50 lines of advice, each followed by 25 keywords and 25 hashtags for sharing or yes. Quick context: commercial actors are all sample return missions have proved access to asteroids to extracted resources, all of which excellent size, friend. Also business. Here is how the three options comparing solely opinion option, focus, ideal use, public talks, vertical graphic or PDF. Number 2, expanded deep academic format. 50 finds brief research detailed 5 to 6 page documents. 3, investors 1 pager recommended sharp high values. Bakers 1 page profession. Since you are focusing on the business potential of SOI pictures, ideal to show that you asteroid mining the $1 trillion opportunity. 4 sharp insight bullets, risk reward. Asteroid mining the $1 trillion opportunity, investors 1 page theme from science fiction to scalable. 8 strongest business case questions: can asteroid mining delivery fast? Will partnership with NASA, SpaceX or robotics and autonomous navigation unlock scalable? Should investors prioritize near-Earth objects? Can space refining cut Earth recently expenses and create a circular orbital economy? Will early propellant markets, LOX, methane, build cash flow before metal extraction? Could digital twins and mission simulation? Should public transparency and sustainability be built into inside quadrant? factor, risk, high caps, reward, multi-trillion dollar resources access, platinum, nickel, what factor, key insight, redesigns, NASA will return, roadmap 2025 to prospecting and in space propellant 2035 plus large scale mining and orbital refining and 50 advisory sentences phrased as question mark. Should you treat asteroid mining as a long or water volatiles for in space fuel production deliver earlier revenue than could small iterative prospecting set small sets de-risk fields? Should you evaluate targets first by delta V and accessibility, not just by reported? Will in space refining and manufacturing reduce? Should partnership with national space agencies be a core? Could robotic for system be the scalable way to operate on low gravity rubble pile asteroids? Should you design mining platforms to be modular and relate targets? Will investing in autonomous navigation and adaptive control betting on remote human intervention? Could producing propellant LOX or LH2 or should legal counsel be on the funding team to navigate property and resource law? Will building on earth proven mining expertise? Should you prioritize near earth objectives, NEOs, timelines? Could a staged business model prospect extract volatiles? Should you plant data rich prospecting spectros? Will collaborating with satellite servicing and should you design your mission architecture to minimize single point? Could public transparency about environmental and economic impacts, outreach and education be refunded? Propose. Will using digital twins and missions cut test cycles and program risk? Should you consider spinning of IP or could looking in launch and ops partners? Should insurance and liability strategies be established? Will creating open standards for could a staged financing approach tied to tech? Should you model commodity price collapse scenario? Will integrating closed loop life support or resources loops add resilience for? Should you plan for? Could teaming with terrestrial miners shot? Will near-term wins easy successful early and aggressively? Could government accelerate commercialization via predictable procurement for propellant or in space service. Should social impact and equity assessments be built into strategy to avoid extraction? A single big asteroid bed. Should you hold strict contained to avoid scientific or legal blowback? Could an early focus on robotic software be? Will a clear IP sharing policy attract academic partners while protecting core commercial tech? Should you expect and plan for multi-year timelines between demo and commercial cap? Could montaging sensor and morphing reduced geopolitical risk and spread cost for large demonstration missions? Should you create contingent for stranded in space assets and the cost of management? Could dual use technologies, terrestrial mining, deep sea robots? Will a governor's roadmap for conflict resolution over resources be capital? Should you factor in export control and national security rules early for any tech with? Could workforce development program, steam pipelines, specialized training secure the talent you will need in a decade? Will transparent cost and scheduled reporting to stakeholders build credibility more than gloss claims? Should contingency funds be reserved for efforts? Could a careful PR strategy that highlights such infrastructures benefits when public support? Will collaborative consortia in academia plus government accelerate standards certification market creations? Should leadership keep a iterative mindset the values technical valid? Please like, subscribe and comment. Another video also here. You will see.
Asteroid mining has evolved from a distant dream into a catalyst for a new industrial age. By unlocking vast reserves of precious metals and rare elements from space, this emerging field is attracting the attention of investors, scientists, and policymakers alike. The prospect of innovative solutions to Earth's mineral shortages and environmental pressures. As technology advances and investment accelerates, the vision of harvesting wealth from asteroids is quickly approaching reality, marking a pivotal shift in how humanity may secure essential materials for the future. Driving this shift are remarkable technological breakthroughs. Robotic prospectors and artificial intelligence now make it possible to pinpoint and evaluate promising asteroids with unprecedented precision. Enhanced propulsion systems have made missions to distant space rocks more practical and affordable. Recent efforts, such as Astroforge's Odin spacecraft and NASA's Psyche probe, are actively demonstrating the extraction and analysis of metals directly from asteroids. These innovations are laying the foundation for processing materials in orbit, rather than on Earth. As these capabilities mature, the stage is set for new economic opportunities that will reshape how resources are sourced. Momentum continues to build as private investment surges and supportive policy frameworks take shape. Companies like Astroforge are securing major funding, reflecting growing confidence in the commercial potential of space resource extraction. Governments are guiding the industry's development through executive orders and streamlined regulations, while international agreements, such as the Artemis Accords, foster cooperation and uphold legal standards. Yet, competition for access and ongoing debates over ownership and distribution are shaping the geopolitical dynamics of space mining. How these forces interact will be pivotal in determining the industry's future direction. However, the path forward is not without obstacles. Advanced technology is required to operate in the harsh environment of space, driving up costs and complicating engineering challenges. Environmental concerns, including space debris and the impact on celestial bodies, add further layers of complexity. Unresolved legal and ethical questions surrounding resource ownership and distribution underscore the need for robust international cooperation and clear policy guidelines. Navigating these issues through responsible practices and global consensus will be crucial for the sustainable advancement of asteroid mining, ensuring readiness for what comes next. As the industry matures, the effects of asteroid mining will extend well beyond the extraction of rare metals. A reliable supply of space-derived resources could transform global supply chains, reduce reliance on terrestrial mining, and lessen environmental impacts. Sectors such as electronics, aerospace, and renewable energy stand to gain from this abundance, fueling innovation and economic expansion. Ultimately, harnessing resources in space will be essential for establishing sustainable settlements beyond Earth, supporting ambitions for lunar bases and Mars colonization. This new era promises to redefine humanity's relationship with our planet and the cosmos, opening doors to possibilities that reach far into the future.
This is the second video attached, and some
Asteroid
images be including. This is the images vying asteroid mining. You will see and entertain. This is also one space asteroid mining, the $1 trillion space. Important images, 3D effect, asteroid hole, lot of these are these very interesting. Moon, and the second one, race to the moon, new space gold rush, metallic orbit 3D asteroid, now metallic 3D. This is the busy. Here you will find out what is that. Great asteroid mapping run, Swaram asteroid mapping, ISRO fueling future rocket, ISRO fueling future rockets, ISRO fueling future rockets. Lunar mines begins. Many photos have you will find asteroid mapping run, mapping asteroids forum, asteroid resource versus Earth GDP, how to grow, asteroid resources versus Earth, asteroid resources versus Earth GDP grow, cosmic gold awaits. Asteroids riches, untapped space wealth. This is the whole moon 3D figures. Thank you, friends. You will reach the episode. Please like, subscribe, and positive or negative comment. Any comment I will receive positive. Thank you, friends.